Hi there, welcome to this tutorial. This is Teacher Raya from Elimuhab's Math. We are going to do question 11 from Necta Form 4 2015 math paper. So the question is about linear programming. What I would like you to do is read the question first and then pause the video and then come back and compare your solution to mine. So that means you're going to need graph paper, pencil, and a ruler at least. Okay, so good luck and let's start. Okay, so the question says a small industry makes two types of cloth, type A and type B. Each type A takes 3 hours to produce and uses 6 meters of material, and each type B, so I'm going to put that in blue, takes 6 hours to produce and uses 7 meters of material. The workers can work for a total of 60 hours, so we got a total of 60 hours, and there is 90 meters of fabric of material. Okay, if the profit on a type A cloth is 4,000 shillings, so we got profit here, 4,000 shillings for type A, and type B makes 6,000 shillings profit. Find how many of each type should be made for maximum profit. Okay, so what we have here is two types of cloth that are going to be made. And then we're given the time it takes for each material to make, and we're also given material for each fabric to be made. And also we're told the profit for each item for each type. Okay, and we are asked to maximize profit. So we need to find out how many types A and types B this industry should make in order to maximize profit. Okay, so before you do anything, you need to define your variables. So we're going to start with that. So let X be the number of type A clothes. Okay, can I spell? And then let Y be the number of type B cloth. Okay, so that's important. The next thing you need to do is just make a small table so everything is clear in your head and you haven't missed anything out. So we're going to say, let's say we've got here type A, okay, then we got type B, and what do we have? Time to produce, so production time. Okay, production time. What else do we have? We have material, how much you need for each material. And then what else are we given? Is a profit for each type. So we've got profit here. Okay, now let's put the values in then. Okay, so we've got for type A, it takes 3 hours to make. Okay, so 3 hours type A, and then it uses 6 meters of material. And then the profit for type A is 4,000 shillings. Okay, so this is in shillings. And now let's go to type B. Type B takes 6 hours to make. Okay, so must be a bridal dress or something, 6 hours to make. And how much? It takes 7 meters. 7 meters you need to make type B. And the profit for that one, if you sell it, for each item is 6,000 shillings. Okay, so we've got all our data here on the table. Now we need to know, with all this information, what do we need to do? We need to have objective function, okay, because we're going to use mathematics to make a model, okay, to find out what's the maximum, what's the number of type A and B to be used in order to maximize profit. So what you need is the objective function. So the objective function then, what's your objective? Is that profit is going to be maximized. So we need to maximize profit, and that's going to be equal to for each type A is 4,000 shillings. So for X number of type A, so this is X here and this is Y. So it's going to be 4,000 X, and for each of type B, it's going to be 6,000 times numbers of type B, which is Y. So that's going to be 6,000 times Y, which is 6,000 Y. This is our objective function. Okay, what else do we need to do to complete our mathematical model? We need to have something to work with. Well, we have all these conditions here: fabric, time, and the profit. So we need to put it mathematically in order to work with it. So for the first one we have is the constraint of time. Okay, so we call them constraints. These are like conditions basically. You don't have the whole time in the world. You only have a maximum of how many hours? We're told 60 hours here. So 3x plus 6y has to be, you can't write equal, it has to be less or equal to the maximum time that's given. Now you can simplify this by dividing by 3 throughout, or you can just leave it as it is. I'm going to simplify by dividing by 3 throughout. So this will give me x plus 2y less or equal to 20. That is my first constraint. The second one is a constraint of material. Okay, so I need 6 meters for type A, so that means 6x, and I need 7 meters for type B, so that means 7y, and the maximum I have is 90, so I could use the whole of 90 meters or less, but no more. So I need to use a less or equal to 90. So this is my second constraint then. Now you need to make sure that all the units are the same. In this case, the units are all the same. The times are in hours and the measurements are in meters. If not, you must convert and they have to all be the same. Okay, so I've got 2 more constraints. Okay, the non-zero variables. So we can't have a negative amount of type of cloth. So that means X has to be greater or equal to 0 and y has to be greater or equal to 0. So these are now my constraints, these ones here. And I'm going to work with these together with that in order to come up with a solution for this industry. Okay, so let's go and graph this information then. Okay, so all I have here, I brought forward my objective function, which we have done that before, and then all our constraints are here. Now what we need to do is use the graph in order to decide on the number of type A and type B. But before that, we need to produce the tables. So for the first one then, x plus 2y less or equal to 20, we make a table, but we put the equal sign. And the values that you need, so you need x and y, you just need one of them is 0 for x and the other 0 for y. And then you find what is missing. You just need 2 points in order to draw the line. Okay, so for this function then, when x is 0, 2y is 20, that means y is 10. When y is 0, x is equal to 20. You've done that table. I'm going to do the next table as well, so that is out of the way. Okay, so this is for this one here, 6x plus 7y. We put an equal sign in order to get the points. So x, y, when x is 0, when y is 0, you find the missing number. So when x is 0, then you have 7y equals 90, and this will give you y equals 12.9. When y is 0, you got 6x equals 90, so x is equal to 15. So now we can go ahead and graph our inequalities over here. I can start with the easy one. X greater or equal to 0 is that way. Anything that way is good. That means I don't want anything the other way. Okay, so we normally shade the region that we don't want or does not satisfy. Okay, so that one is done there. Now we're going to do this one. Y is greater or equal to 0 is from this line going upwards. So that means I don't want that way. Okay, so the next thing we're going to draw is this line here. I have 2 points. So our first point is 0, 10. So x is 0 is only y-axis. I go up here and make a point. And then when x is 20, y is 0 is this point right here. Okay, now you get a ruler and a pencil and you draw your line. Okay, so just draw a nice line. Okay, so that's a line, and then we make sure we label it. So this line here is x plus 2y equals to 20. But because our original function is inequality, we need to decide which side of the line satisfy this condition. So is it this side or this side of the line? So that side or this side? Okay, so we can pick a point on this side and see if it works. I'm going to pick 0, 0, which is on this side of the line. I'm going to put it in there, 0, 0. So when x is 0, I get 0 plus 0. Yes, 0 is less than or equal 20. 0 is less than 20. So I'm happy with that side. That means I'm going to shade that region over here. Okay, and now for this line then, when x is 0, y is 12.9. So 12.9 roughly would be around here, and then when y is 0, x is 15, so it's right there somewhere. And now we pick a line and we just draw a nice line. What color should I get? I'll try this color. So 12.9 is somewhere around here, almost halfway there, because almost 13. So that's a line, and now I'm going to label this line for anything. So that line is 6x plus 7y equals 90. And now I'm going to test this line too. Which side of the line is good? That side or that side? Okay, we know that area we can't use anyway because it's shaded by the blue line. But we got this line, we need to know, do we need that area or do we need this area? Okay, so we're going to take 0, 0 again. So that means this side of the line. So 0, 0 into here. And then we say 6 times 0, 0, 7 times 0, 0 is less than 90. Yes. So that means we want this side of the line. We are going to shade that region. We don't want that region, does not satisfy. Okay, so we've got this region that's not shaded, and we've done all our shading with all our inequalities. That means this region here satisfy all the inequalities, all our conditions, and this region is called the feasible region. Okay, so what happens is, happens on the corners of the feasible region, that corner there, this corner here, and this corner here, and this one of them will give us the number of items that we need, which will give the maximum profit. Well, 0, 0 is not going to really give us anything, because if you put 0 in our function, you just get 0. So we don't really need to test 0, 0. So let's just put this point here, I'm going to call this point A, and that point is 0 and 10. And then I've got another point here, I'm going to call this is point B, and x is 15 there, and y is 0. Okay, so now I've got this point here, which I'm going to call C. At that point, x is 6, x is 8 and y is 6. So this is 8, 6. So I've got 3 points, which I'm going to test and see which one of these values is going to give me the maximum profit. Okay, so let's test those points then. Okay, so we've got point A as x0, y10, and then point B, we have x15, y0, and then the point C, we got x8 and y6. What we're going to do is substitute the values of x into our objective function. Remember, this is our profit function, and then see what we get. So when x is 0, we get 0 plus 6,000 times 10. So this will give you 60,000. And the total is 60,000 shillings. Okay, and now for point B then, we've got x15. So we put the values in there. 15 times 4 is 60. And then we've got the 40, so that's 60,000 again. Plus 0 times 6,000, that will just give you 0. So this gives you 60,000 again. And for this point C over here, we put 8 times 4,000, so that 8 times 4 is 32, and then we got the 32,000 plus 6 times 6 is 36, and then we got the 30. So that 32,000 plus 36,000 will give you 68,000. By the way, this was 60,000. So we can see this point here, point C, this is the one that's going to give you the maximum amount, the maximum profit. So this point is called optimal point. This is optimal point because this is the one that's going to give you the maximum value. So you conclude that in order to maximize, okay, in order to maximize profit, the industry will need to make type A and 6 type B clothes. Okay, so that is your solution then. Please remember to like and subscribe. Thank you for watching, and bye for now.